Okay, in this video, we are going to cover something that's a little bit odd about Go. So Go is actually a functional programming language. In other words, in order to accomplish things that you're doing, you write functions that do individual little tasks, and then you call all these individual functions to make your program do what you want it to do. However, Go actually has some pretty cool stuff in it to the point where it's very similar to C, to the C programming language, but you actually can create the semblance of having classes inside of Go. So in other words, you can have functions related to things, and I'm going to explain to you how to do this in this video. I'm going to try to keep this very, very simple. So hopefully you'll kind of understand how this works as we go. I'm not going to get into anything complicated. So the first thing I wanted to do is I wanted to show you a function called main. So this is a very simple program. We have a package called main, and if you watch the other video on packages, you can kind of understand how that works. We have imported a class that's in, or a package that's inside of Go, that's included with Go, called FUMP. It's a FMT package. And then we've got our declaration for our main entry point, which is func main, and then what we want to do, which in our case we're calling FUMP print and then hello world. And so if I get out of the file and we just type go run test.go, you'll see that it just says hello world. And so now what I want to do is we're going to VI this file again, and we're going to come up here and try something else. We're going to write a new function that's my first function, and we're going to pass it I am great. And so now we have to actually write a function so that we can do this. So we're going to say function or func, and then we're going to say my first function, and we're going to accept a variable. We'll just call it st, and it's going to be a string, and we're not going to return anything. We're going to keep this as simple as we can. And so now we're just going to tell it fmt or fump dot dot print, and then we're going to say st, and then we're going to add to it okay. And so at this point we're going to save the file again, we're going to run it again, and actually hold on. So I have a problem somewhere here. My first function, that's the end of that, Oh, I forgot the end of this. All right, so we'll run it again. And so you see hello world, and then I am great, are you sure? So we're just going to VI this file again. And so this is an example of a functional programming language. You basically can go in and write functions and call them from anywhere you want to call them and make them do whatever it is that they do. However, in a class or an object-oriented language, we really would like to associate that function to an object so that we can only call it from inside that object. We can't call it from outside the object because it is related to a bunch of other things, and they all of these functions are all require certain variables to be set. They require certain things to be done. And so I really would like to have this association that you don't have in a programming language like C. So here's how you do that inside of Go. So the first thing we're going to do is we're going to create a new type, and we're basically going to create a structure. So we're going to say my struct, and it's going to be of type struct, and then we're going to just declare a couple variables in here. So we'll just say var1 is going to be a string, and var2 is also going to be a string. And that's all we're going to do inside of our structure. So there's no magic here. All we're doing is we're declaring, if you think about it in an object-oriented language, you're declaring a class. But in this case, it's just a structure with variables associated with it. But now what we're going to do is we're going to come down here and we're actually going to tell my first function that we want it to be associated with the my struct uh, that we created. And so to do that, all I'm going to do is I'm going to put a declaration here in front of the function telling it that that function is actually part. So I've declared a variable called f, and then I have it associated with a pointer to my struct. And so by me declaring this function as being part of the structure that we have above, and that's all that we have done is we've created a structure and we have the function associated with it. So if we save out of this and we try to go run it again, you're going to see that it's saying undefined function. It no longer knows what to do with my function or my first function because it's no longer a global function that's part of the main package. It's actually associated with my struct. And so what we've got to do now is we've got to come up here and we're going to declare a variable, and we'll just say ms, and we'll declare it as a type my struct. And then what we've got to do here is we have to actually tell it that we want to call the same function we were calling a second ago, but now in order to call it, you have to call it from an instance of my struct. And so we're going to save that. We're going to come over here and try to run it again. And you'll see that it runs, it's doing exactly the same thing that it was doing a moment ago. But the difference is that now, simply by adding the structure, a pointer to the structure that we want this function to be associated with, we have now got a semblance of a class structure where we've actually associated this function with a class object, and I now need to have an object or an instance of that object in order to call the function. So you use dot notation the same way you do in Swift or in any other programming language that is object oriented, and then you're calling the function from within that instance of this, in this case, a structure. So this is how you can group your functions not only in packages, but you can also within a package have different structures that have different functions associated with them so that they are all related to each other during the program execution and programmers using the different objects.